Hello students, and welcome to another video. I'm your teacher, Mr. Flint, and today we're going to be working on how we prepare a dilute solution. When I order chemicals online and they get shipped to me, they don't send me I would say a solution that's of the desired concentration that I'm looking for. They send me a very concentrated mixture of chemicals. So like for example, when I order hydrochloric acid, most of the hydrochloric acid that we work with is 1.1 molar in strength. They send me 12 molar. It's when you pull off the cap, it's literally reacting with the air. It's very strong, and you shouldn't be working with it as it is right there because it will hurt most students and damage other equipment. So what I like to do is dilute the solution down to a desired strength so that we can use it in class. So we want to use a 1 molar HCl, not 12, right? We need to dilute this down a little bit, okay? Now, how do we do that, okay? So hold on. In this problem, okay, I'll just step back a second. So in the lab, I have 12 molar, but here I have a 1 molar, and I want to dilute it to a 0.5, right? And so the question is how much water do I need to put into a desired amount to have 250 milliliters of this prepared? Okay, so let's go through and let's work out this problem. They're not that hard to solve. Once you kind of get the layout, it's not very challenging. But it is something that I do quite frequently in the lab in creating dilute solutions. You can do this with Kool-Aid at home. You can do this with other things. You actually do this with Kool-Aid. If you ever buy those frozen juice packs, the little cylinders, you can put them in, you put water in it, you're creating a dilute solution. All right, it's not as concentrated, okay? All right, so let's go through and let's work out this problem. But before that, let's examine on the back of our periodic tables, there is a dilution formula for solving this. So let's write out this dilution formula. This is given to you. You don't have to memorize it, okay? All right, so the dilution formula is M stock, okay, we'll see it there, multiplied by the V stock, okay, and that's equal to our M dilute by our V dilute. And in these problems, you're always going to get 3 of these things. You need to solve for one of them, okay? So if you go through this, you can quickly see which one's which. So you have a stock solution of an aqueous 1 molar HCl. So our stock solution is 1 M HCl, okay? And our V stock, well, it doesn't tell you what that is. So we have to go then to our second part. It says how many milliliters must be diluted, so that's this, okay, with water to prepare 250 milliliters. Okay, so what we're trying to create is 250 milliliters of aqueous HCl, and we want a dilute concentration of 0.5 m. And we can easily figure this out just by looking at them, right? 1 is greater than 0.5, so the stock solution has to be 1. It can't be 0.5. You can't be diluting something to a lower strength than it is. All right, so it has to come from a place of higher concentration. So this one's always going to be on the stock side. It's always higher, so it's kind of obvious. But the only time the only time we can get this confused is, well, is this 250 go here or here? Well, you're trying to create 250 milliliters. We're just trying to figure out how much water do we have to add to that to make it dilute. So what you got to do now is just solve for V. So in order to do that, I'm going to divide this side of the equation by 1m and move it over here to 1m. And now my big M's cancel, and I'm now left with milliliters, because what are we looking for? How many milliliters must be diluted? So what we're going to do is do 0.5 times 250. That gives me 125. Okay, so if I have a 1 molar solution, okay, I need to pull out 125 milliliters. Okay, so what I'm going to do is I'm going to siphon it out. Okay, I'm going to talk about this in class, but what we'll do is I'll take out 125 milliliters and I will put it into one of these, and then I will fill the rest of it up with water to dilute it. Okay, and you're going to do this in the lab. But how to solve these problems? It's pretty straightforward. Plug in your information, solve for the missing variable, and then you can know how much you need to remove from the container, right? Because when I'm working with those high concentrations, I will pull or measure out a specific amount of that HCl, and then I'll dilute it with water to get it to a desired concentration that is much less strong and toxic, okay? Thanks again for watching. If you have any more questions, please come talk to me. But this is just the basic layout. But some of the complexities of how we do them in the lab, we're going to do a lab on that and have you work with the instruments, okay? Thanks again for watching.